Good morning, you guys. Sorry, I haven't talked this morning. It's 5 a.m. You're probably all sleeping. My daughter just woke up with a fever, so my apologies for not being there, but I will make a video of what you're doing. Your quiz is 6-1 to 6-3, so there is this worksheet, these 11 problems that we're going to work through together right now, or if you want to work ahead of me and just be checking your answers against mine, that's great too. And then you will take a quiz in the second half and call it good. So hang out with me here or work ahead and check your answers. It would probably be a good idea, even on the quiz, to make a list of all your perfect squares, perfect cubes, things like that. So I'm going to make a list right here up at the top. 2 times 2 is 4, 3 times 3 is 9, 16, 25, 36, 49, 64, 81, and 100. So those are the perfect squares, right? Okay. Really the perfect cubes that we do the most with. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. Those are the most common ones. So what we're doing in this first setup is we're just simplifying an expression here. Probably should have grabbed my calculator. We'll see how this goes. So the square root of 96 x to the 5th y to the 8th, you are looking for the perfect square and the not so perfect square, right, is how we usually set it. So 96 divided by 64, 96 divided by 49, 96 divided by, find the one that is the perfect square that this is divisible by. And you always start high and work your way low, right? So the biggest perfect square that 96 is divisible by is 16. 16 times 6 is 96, okay? And then keep in mind, this is square roots. So when you're looking at the variables, you need to be able to divide by that number. And 5 is not divisible by that number. So then you check the next number down. 4 is divisible by that number. But then you still have an x over here that we can't forget about. So that would be x to the 5th when you add those together. And then y to the 8th, that whole thing is divisible by 2. So that's going to go here. And now you actually take that square root. So the square root of 16 is 4. The square root of x to the 4th, you're dividing by 2 here. So x squared. And then y to the 4th. And then you still have the square root of 6x. So this would be your simplified form for that one. Number 2. On number 2 here, you're taking a cube root. So the first thing you want to do is see when there's division involved, when there's this fraction here, you want to see if you can actually do that division. So can you actually do 216 divided by 8? If you can, that'll probably simplify the problem a lot. So check that first. Plug it into your calculator. 216 divided by 8 is 27. So we get the cube root of 27. And then we have x to the 4th. Okay, so that simplified things. Now we see, can we break that into something that is a perfect root and a non-perfect root? And if you recall, up here, we said 27 is a perfect cube. So that's going to go on the perfect side. That means there's nothing on the other side. It's a 1, essentially, which you don't need to write in. X to the 4th, we can do x to the 3rd, right? Because it has to be divisible by 3 now. So x to the 3rd there, which leaves us with just an x over here. So when you simplify that, the cube root of 27 is 3. the cube root of x to the third. You're going to divide that. 3 divided by 3 is 1, so that's x to the first power. And then the cube root of x is as simple as you can go. Okay. All right. This next one is a fifth root. If you recall on your calculator, you would put in 5 math, and then the number. Nope. 5 math 5, sorry, is going to give you this, right? 5 math 5, and then the number, sorry. So plug that into your calculator right now. Get your calculator out if you don't have it out, just for a little practice. So 5 math 5, 32, hit enter. What you'll see is 32 is actually a perfect fifth root. Again, I don't expect you to know that off the top of your head, but you can plug it into your calculator. So if we break this into perfect and not perfect, you would put the whole 32 on the perfect side, okay? Because we can take the fifth root of that. This one, you're looking at, can I divide by the index? And my index is the 5. 3 is not divisible by 5, so we're actually going to put all of those on the non-perfect side. And then you have z to the fifth, and that is divisible by 5. 5 divided by 5 is 1, so that we can do. So put that on the perfect side, and then we'll simplify that. So the fifth root of 32, we said was 2. Z to the fifth, so 5 divided by 5 is just going to give you z to the first. But then you still have the other side that is not the perfect fifth root, and that will be your answer. All right, number 4 through 8. This is multiplying and dividing. This was 6, 2. So you multiply and divide first if you can, and then you simplify from there. And just keep in mind you cannot leave radicals in the denominator, okay? So we got to rationalize that. So looking at number 4 here, you are going to multiply. 8 times 40 is 320. Okay, so multiply the numbers. Sorry, I heard a critter outside. Then x to the fifth and x squared, you add those together. So that's going to be x to the seventh. And then once you've multiplied, now we can break it down into something that works a little nicer as perfect squares. So you have 320. Remember your list of perfect squares. So you're going to take that list. Okay, so here's our list of perfect squares. You're going to go 320 divided by 100, doesn't work. 320 divided by 81, doesn't work. 320 divided by 64 does work. It is 64 times 5, if you plug that into your calculator. Then we're going to find the perfect square. So if it's x to the seventh, we're looking for, is that divisible by 2? It is not. But x to the sixth is divisible by 2, right? You just work your way down from that number until it's divisible by 2. So x to the sixth is divisible by 2. There is one x left. So it's going to look like this. And then we're going to take the square root. So square root of 64 is 8. X to the sixth, remember it's a square root, so divide by 2, you get x to the third. And then we can't do anything with this other stuff, so we just leave it as the square root of 5x, and that is your most simplified answer. Okay. All right, number 5. Again, we want to multiply these together. So this is going to be the cube root of 2 times 16 is 32. And then you have x to the 5th and x to the 3rd. So that's x to the 8th. And then y to the 4th. And y is going to give you y to the 5th. Okay. And if you recall the list of the perfect cubes, we did 8, we did 27, and we did 64. The only one of those that 32 is divisible by is going to be 8. So that's going to be 8 times 4. Remember, I always put the perfect on the left side because we're going to simplify that side. We won't be able to simplify the right side at all. So then you take x to the 8th and you think, can I divide that by 3? And you can't. So then work your way down. X to the 8th is not divisible by 3. 7 is not divisible by 3, but 6 is. So x to the 6th here, which means we have x squared on the other side. Then you look at y to the 5th. 5 is not divisible by 3. 4 is not divisible by 3, but 3 is divisible by 3. So y to the 3rd, okay? And that leaves us with y squared over here to get it to be y to the 5th. And now you take the cube root of that left side. So the cube root of 8 is 2. The cube root of x to the 6th, so 6 divided by 3 is 2. And then y to the 3rd, 3 divided by 3 is y to the 1st. And then you have the cube root of 4x squared, y squared. So this is your simplest answer. You don't need the 1, so you could just ditch that one if you don't like it there. But that will be your answer. All right, number 6. So this one, if you, again, can divide right off the bat when you see that division bar, then divide. So 36, you can't divide anything. But your variables you can divide. X to the 5th divided by x to the 3rd. Remember, that is x to the 5 minus 3. You subtract them, which would be x squared. So you have right now the square root of 36x squared. And that is actually a perfect square. So this one works out really nicely. Square root of 36 is 6. The square root of x squared is x. And that is your answer. All right, number 7. This is one of the trickier ones. This is taking a cube root, but where you have to rationalize. So remember, what we do to rationalize, you can essentially think of this as a cube root over a cube root, which means we have to get that cube root out of the denominator. So because it's a cube root, we want what this equals over here. Okay, we want this to be a perfect cube so that we can actually take the cube root of it to get rid of the radical. Okay. So what you're going to do to make that happen is you're going to multiply by the cube root of something to make these perfect cubes. Well, if it's x squared, if I multiply that by x, that will get me over here when we multiply the cube root of x cubed, and that's a perfect cube. Okay. The y, I have a y right now. I would have to multiply by y squared to make that y cubed when I multiply across. So notice this is an equation, right? I'm saying this times this gets me equals this, okay? So when we do that, we can't just multiply the denominator by that. We got to multiply the numerator as well, okay? So now I'm going to multiply across. So multiply across here, you get the cube root of 3xy squared. You can't do anything with that. That's going to stay put. The cube root of 3xy squared. Don't try to do anything here. Don't try to do anything here because that's going to undo the work that we just did to make that a perfect cube. Because since this is a perfect cube, we can just take that perfect cube, okay? So the cube root of x cubed is x. The cube root of y cubed is y. And that is your final answer. Okay. All right, number 8. This one, you will divide as much as you can, if possible. So looking at, 5 over 2, we can't divide that, so that's going to stay put. But this we can divide. Okay, so if I rewrite this, it's going to be the square root of x to the 4th divided by x squared. You subtract that, so you get an x squared on top. Okay, so we still have a square root of 2 on bottom. We have a square root of 5 on top. But now all we have is an x squared in the numerator. And then we move to this guy. You have a y to the 1st and a y to the 3rd. Now, if you want to set that up as this, y to the 1 minus 3, that's y to the negative 2nd in the numerator. Remember, that moves it as a positive y to the 2nd in the denominator. I always just think of it like this. If we subtract these, it's 3 minus 1, the bigger numbers on bottom, so keep your answer on bottom. That's up to you how you want to view that. But now we have some perfect squares. So the square root of x squared is just x, so put that out in front, but we still have the square root of 5. And then the square root of y squared is y, so put that out in front, and we still have the square root of 2. So you're very close to done here. You just have to rationalize it, which means you cannot leave the radical in the denominator. So we're going to multiply by the square root of 2 over the square root of 2. And when we do that, you get x times the square root of 10 over, this is y times the square root of 2 times the square root of 2. Well, anything times itself is that number underneath the radicand. So this is going to be 2 times the y, and then you're done. Okay. All right, next one. So this is on to the last section, 6.3, that is on your quiz. For this one, again, you're going to simplify as much as you can, and you can't leave radicals in the denominator. So let's start here. We are going to break down these radicals into something a little simpler if possible. So we still have the 5 out in front, and then that 32x will break down. So what perfect square is 32 divisible by? That would be 16 and 2. And then the x is not a perfect square. So that's going to look like that. So 16 being the perfect, rad 2x being not perfect. So this is 5, this is multiplication that we're doing, times the square root of 16. So 5 times 4 is 20 times the square root of 2x. Okay, then we have plus, now come over here, you have this 4 out in front, and then perfect square and not perfect square. If you can't find it, remember what I said in class. We want this to be the same. So there's a good chance that is going here. So ask yourself, could I divide 98 by 2? I can. It's 49. And then don't forget you have the x there. So this is 4 times 7, or 28. And then rad 2x. Okay. And now we can simplify this. So 20 plus 28 is 48. And then we still have the square root of 2x. Okay, and that is your simplified answer. All right, number 10. This is a binomial times a binomial. This looks very close to being able to use the shortcut, but this is not the same as that, right? So you actually do have to FOIL this one. No shortcut here. So let's FOIL. The square root of 3 times the square root of 3 is the square root of 9, which is 3. Okay, so that's your first. Your outside, so we're going to multiply these two, the square root of 3 times 2 rad 7. The radicals you can multiply. So rad 3 and rad 7 is rad 21, but then you have this 2 out in front. So this is plus 2 times the square root of 21. Okay, then we do our inside. So a negative rad 7 and a rad 3 is a negative rad 21. And then our last, you have a negative rad 7 and 2 rad 7 that you are multiplying. So this is going to be minus 2, and then it's the square root of 49, or you could right off the bat say the square root of 7 times the square root of 7 is just 7, right? So simplify that. 2 rad 49 is 2 times 7, which is 14. So you have, and this is a minus still, right? So you have 3 minus 14 for the first part. That's a negative 11. And then you have this section, 2 rad 21 minus rad 21. You can think of that as having a 1 out in front there. So 2 minus 1 would just be 1 rad 21. That's a positive 1. So this would be a negative 11 plus the square root of 21. And there is nothing else you can do there. So that would be your simplified answer. All right. Number 11. This one we're going to use a shortcut on. This is finding the conjugate, right? In order to get rid of this expression in the denominator, we need to multiply by the conjugate. So remember, the conjugate is whatever your denominator is, you're going to multiply by those same numbers, but you're going to change the sign. So if this is a plus, you make it minus. If that's a minus, you're going to make it plus, okay? That would make it the conjugate, but you have to multiply by it over itself so that we're essentially multiplying by 1. Okay, so we're going to multiply these together. Keep in mind the shortcut when you are doing conjugates, right? So the shortcut here is you take the a value and you square it, so the 2, and you square it, and you subtract. It's always subtraction with this shortcut. So the b value, the square root of 3, and you square it. If you don't remember the shortcut, you can always FOIL both parts, okay? You have to FOIL on top on this one, but you can also FOIL the denominator. So here's your setup, okay? We are going to take the shortcut. So this is going to be 2 squared minus the square root of 3 squared. Let's just simplify that right now. So that's 4 minus the square root of 3 squared is 3. So you actually end up, beautifully enough, with a denominator of 1, which is going to make it go away, right? Anything over 1 is itself. In the numerator, you're going to FOIL. So 4 times 2 is 8 minus 4 rad 3. Okay, this is plus 2 rad 6. And then we end with minus the square root of 18. Okay, give me a second to get caught up on that. Okay, so now we simplify that. This one doesn't simplify quite as nicely as some of the other ones have simplified, but that's okay. It doesn't have to. You go as far as you can go. So really the only thing that you can break down here is the square root of 18. You can't combine these guys because one's a 3 and one's a 6. Those are not combinable. But the square root of 18 is the square root of 9 times the square root of 2. So that would be 3 times the square root of 2. Okay, and that's subtraction. So this is going to be, and we're just going to write this down because this will be our final answer, 8 minus 4 rad 3 plus 2 rad 6 minus 3 rad 2, right? That came from this guy, from the square root of 18. That whole thing is over 1, which means you can ditch the 1 and just write your answer like that. All right. So sorry to not be there. Kenzie's got a fever and just not feeling good. So hopefully I will see you in your next class period. Have a great day and good luck on the quiz.